now that we know what irrational numbers are, we're going to look at how to compare them. And there's a couple different ways that you can compare irrational numbers. You can either just look at two and kind of just see which one might be bigger, or you can kind of put a bunch of them on a number line and then kind of put them in order from least to greatest, essentially. So let's dive in comparing two different irrational numbers. So with each set of numbers, we're going to just see which one's bigger. So if I had 5 squared, we know that is 25. And if I have the square root of 125, I don't know that off the top of my head. I'm trying to figure out what times itself gives me 125. Well, it's kind of close to 11 because the square of 11 is 121. So even without knowing specifically what the square root of 125 is, I already know that 5 squared is going to be bigger. And hopefully you remember that sign from like first grade, the little alligator likes to eat the bigger meal, so the mouth faces towards the bigger number. So how to compare numbers is if we don't need specifics, if we don't need decimals and stuff, you can just find kind of an estimate and then go from there. So here we estimated the square root of 125 as 11, and we knew that 25 was bigger. So now let's look over here. The cube root of 136. I do not know that off the top of my head, so we can use a calculator. And that's about 5.14. Well, then 183 divided by 2, that's going to be like 90 something. So which one's bigger? Well, 90, of course, is a lot bigger than 5, so this number is going to be bigger. So once again, we don't need to get into specifics if all we need is to know which one's bigger than the other. All right, here we have the square root of 75 and the cube root of 75. This one we don't even need to do any calculations of. Of course, the square root is going to be bigger because you're trying to think 2 of the same thing multiplied giving 75, opposed to 3 of the same thing multiplied to give me 75. So the square root is going to be bigger because you only need 2 of those multiplied instead of 3. Here we have the square root of 48. I don't know what that is, so I can put it in my calculator. And it's about 6.9. And then 4 over 11, that's not even a whole. That's less than 1. So of course, that's going to be less than 6.9. Here I have 2 9ths and 0.34. Okay, those are both essentially parts. Those are both less than 1. So maybe I need to get a little bit more specific to see which is going to be bigger. So 2 over 9 is 0.2 repeating. So 0.34, of course, is going to be bigger. Then if we have the cube root of 284, I don't know that off the top of my head, so we can use our calculator. And we get that it's about 6.5. And then 28 over 4, well, 28 divided by 4 is just 7. So these two are actually pretty close, but the 28 over 4 is slightly bigger. So I want you to finish up this last row on your own. If you have any questions, you can ask me in class. So here's another way to compare numbers. Instead of just taking 2 and seeing which one's bigger, we can just put them on a number line. And we're essentially comparing them all to each other and by putting them in order of least to greatest. But then also we're able to see, based on where they are on the number line, which ones are closer to each other than others. So here in this one, we're going to need to actually get the specifics of the numbers, not just kind of rounding like we were before. So let's go ahead and dive in. So if we have 3.56, that of course will be a little bit more than halfway between 3 and 4. Square root of 27, we need the actual specifics, so we need to use our calculator. That is 5.196, so a little bit past 5. 2.5 cubed equals 15.6. So that's going to come down here a little bit past half. 71 over 3, so we have to divide those. And that is 23.6 repeating. So that would come to be about right here. And then we have 284 cube rooted. So of course we need to use our calculator because we don't know that off the top of our head. And that is about 6.57. So we're coming back to over here a little bit past halfway. And that's the cube root of 284. So the good thing about comparing it in this way of putting it on the number lines, we can see which ones are really close together in value, which ones are maybe really far out there in value. Then also now we know which ones are bigger than each other. So one last little thing that I just want to bring up is estimating the value of irrational numbers if we're squaring them or even cubing them. So obviously we can only be as accurate as how many decimals they give us. So if we have this 3.738294, then that's only as much information as we can put into our calculator. So even though technically this number never ends, we're not going to be able to have a true answer because we're not going to be able to plug every single part of that into our calculator. So we can only really get an estimate, and that's why it asks for estimate, not like solve or anything else, because the most we can do is estimate. So this is one that, of course, we just need to use our calculator. We'll put in 3.7388294 and then square it, and we'll just see what we get. Here we get a nasty long decimal. So I'm getting 13.9748423, and we have to put on the ... because it really does keep going. This is really just an estimate. And I'm going to put the little squiggle estimate sign out front because we know that this is not a complete answer because we did not have every single little decimal attached to it. So let's look at if we had 1.9382, but there's still stuff after. We can only put in as many numbers as they give us. So I have 1.9382 squared, and I'm getting 3.75661924. Again, this keeps going, and I'm going to put a little squiggle out front because this really is an estimate. So I'm going to have you do this third one on your own. So go ahead and put in as many decimals as they give you into your calculator and find out what that is squared. So now let's look at cubing. So what if we had our 2.384 being cubed? We know that there's more decimals attached to it, but it doesn't tell us what else is going on there. So all we have to put in is 2.384 and cube that, and we're getting 13.54935591, and we're going to have to put a ... because we know it continues on. And we can put a little squiggle in front because this is an estimate. Because really, we don't know how accurate these numbers right here are. Since all we have are 3 decimals to put in, technically our number's only accurate to 3 numbers, to 3 decimals. So let's look at the second one. Most of us, our calculators won't even fit all this in, so we'll just have to put in as much as our calculators can fit in. So let's see how much mine can fit in. 8.18394826 and so mine only even goes to here. Maybe yours goes a little bit farther. And then I have to cube that, and the estimate is 548.136378.1, and of course it keeps going on. So this number is a little bit more accurate because we were able to put in so many more decimal places. Whereas this one, technically our number was only accurate to 3 decimal places because that's all that we were able to put in. And in high school, some of your teachers will want you to only show the numbers that you know for sure are accurate, and some won't care. So here we have 3.2. Your answer technically is only accurate to 1 decimal spot. So I'm going to let you finish this one up. Go ahead and put 3.2 in and cube it. Write that down, and of course with a squiggly in front and our ... at the end. But know that your answer really is only accurate to 1 decimal place because that's all we were able to put in. So go ahead and finish that up. If you have any questions on this one or the squared one, you can ask me in class. And that's it for comparing irrational numbers.